Hello class! So it's me again, Engineer John Ray Pacturanan. So this time, ang pag-uusapan natin dito sa lecture video ito is the last part of our topic for deflection, which is the beams with internal pins. So recall lang natin last time, ang napag-usapan na natin ay yung mga non-prismatic beams and kung paano nga natin yon ginawa ng analysis for slope and deflection. So actually, for the beams with internal pin class, parehas din lang naman class ang mangyayari. So, ikakat mo lang siya doon sa internal pin and magkakaroon tayo ng higit sa isang span na i-consider. Okay? So, para mas maintindihan nyo, ito yung ating presentation and magbibigay nga ako ng dalawang examples related to that. Okay? So, simulan na natin. So, sabi dito, beams with internal pins, for statically determinate compound beams, the analysis is the same with the analysis of non-prismatic beams, di ba? However, the boundary conditions is only the deflection of the internal pin is the same at both sides of the cut, but the values of the slope at left, no, pasensya na, at left and right side of the internal pin are not equal. So the next examples will help us understand this topic. So dito, ang pinagkaiba lang class nitong topic na ito as compared sa non-prismatic beam is yung continuity equation natin. Halimbawa class, no, meron tayong compound beam. So this is fixed, tapos yun na nga. And meron tayo ditong internal pin. So A, B, and C. So, pag in-sketch natin, class, yung kanyang elastic curve, so, ganito ang kalalabasan niyan. So, this is the internal pin, and pag ganito siya. Okay? So, this is the elastic curve. Of course, this will be the deflection at B. So, therefore, ang mangyayari, ang ating continuity equation dito, isa lang. Anong ibig sabihin nun? Yung deflection ng B sa AB ay equal lang sa deflection ng B sa BC. So, this is the continuity equation. Ito lang class ang gagamitin natin. For the case of slope, yung slope at B kay AB, so kailangan yung matandaan na they are not equal sa slope at B and BC. So, hindi natin to class magagamit, the second one. Ang magagamit lang natin is yung una nga, which is the deflection. Okay, no? So gusto ko yung i-emphasize. Isa lang ang continuity equation natin ngayon. Unlike doon sa non-prismatic na dalawa ang kinonsider natin. So para nga mas maintindihan natin, so we are going to solve some examples. Dalawa nga. So this is the first one. So yung una, consider the prismatic compound beam as shown below. So ibig sabihin, prismatic siya. Kaya lang may internal pin lang class sa point B. Unang tanong, determine the deflection at internal point B. So, ano yung magiging deflection dyan? Pangalawa, determine the slope at internal point B. And yung pangatlo, determine the slope and deflection under the 25 kN concentrated load. So, yung point B is the internal pin. So, nandito yung 25 kN class. Okay? So, katulad doon class sa previous na discussion ko, I already solved this one. So, all I need to do is to discuss that. Kasi nga, kapag isusulat ko pa siya simultaneously, magiging mahaba ulit itong ating discussion. So, para makatipid tayo, i-discuss ko na lang. So, usually, ang unang step dito class is of course, hahanapin nyo yung reaction doon sa internal pin. At the same time, of course, sa support. So, babalik ka class doon sa discussion natin sa analysis of compound beams. So, di ba nga, lahat ng topic sa theory of structures ay interconnected. No? So, kung hindi mo na master yung previous discussion, most likely mahihirapan ka sa mga present discussions. Okay? So, ang unang step is dapat hanapin natin yung mga internal itong reaction sa internal pin at the same time yung mismong support reactions. So you may verify my solutions class. So yung reaction ko class dito ay 24 kN sa B and dito sa point A 24 kN din siya. Sa C meron siyang vertical reaction na 61 kN and moment reaction na 224 kN. Okay? So ito siya. Ngayon, ang next class is in-sketch ko yung elastic curve for reference. So, di ba, ganito yung magiging itsura ng elastic curve natin, class. So, ang gagawin nyo, class, is i-consider nyo yung dalawang segments, di ba? So, ano yon? Yung AB at the same time yung BC. So para nga lang tong katulad sa non-prismatic beam, ikinonsider mo yung segment AB at the same time i-consider nyo yung segment BC. And each span, gagawa tayo ng equation for moment, equation for slope, and equation for deflections. So dalawang beses ka magdo-double integration method dito. So walang problema sa span AB, ikakat mo lang siya dito. But for span BC, considering the initial load class na dito lang yung 12, ang gagawin natin in order for the 12 kilonewton meter to be continuous, dapat uutang ka ng downward na 12 and babayaran mo ng upward na 12. So I hope walang nalilito dito sa konsepto ng bayad utang sa mga distributed load. And yung 25 kilonewton is of course acting at this manner. Okay? So, I hope that is clear. The next step is, yun na nga, kailangan natin i-establish both the moment functions. So, I select this random as point x and dito naman, this is supposed to be tatlong span to, itang span na una, pangalawa, and pangatlo. And you know naman sa double integration method, ang concern lang naman natin is yung pangatlo. So, we are just referring to this third one. Okay, so pag kinat natin yan, i-establish natin yung moment function. So dito, madali lang siya. Summation moment at x equals 0. Clockwise moment equals counterclockwise moment. So 24 times x equals 12x tapos x over 2 plus moment at x. So moment function x equals 24x minus 6x squared. Sa kanan naman, ganun din. By the way, I already placed the reactions, no? Kasi nga 'di ba, sa computation natin class, this is upward of 24 sa B and downward of 24 considering BC. So for BC class, ang mangyayari, pag kinat nyo nga siya dito, so summation moment equals 0, clockwise equals counterclockwise. Isa lang ang clockwise moment natin dito, this 12 kilonewton per meter, and its length class, kung ito ay x, tapos ito ay 1 meter, di ba dapat x minus 1 siya, kaya 12 times x minus 1 times x minus 1 over 2 equals counterclockwise, yung 24 kilonewton class na mismong reaction, kailangan natin yan isama kasi yun yung reaction sa internal point B that will create a counterclockwise moment class. Tapos, ito mismong downward force na 12 times x, tapos x over 2, then ito rin 25 kilonewton class with a distance of, since 3 meters siya from the point B, so, of course, x minus 3. And lastly, the moment function x. So, the moment function is equal to negative 24x minus 6x squared plus 6 tapos x minus 1 squared minus 25x minus 3. So, these are the moment functions. Ang next na gagawin natin is ipe-perform natin class yung double integration method, di ba? So, performing DIM, the first one is 24x minus 6x squared. So, of course, madali lang naman to. Yung EIY prime is 24, x squared over 2 minus 6, x cubed over 3 plus C1. So, do not forget the C1 Then, that will be equal to 12x squared minus 2x cubed plus C sub 1. So, ito yon. So, on the other hand, EIY prime equals 12 tapos x cubed over 3 minus 2 tapos x to the fourth over 4 plus C sub 1x plus C sub 2. So, the equation will be 12 over 3 is 4. 4x cubed minus 1 half x to the fourth plus c sub 1x plus c sub 2. So, ito na class yung resulta ng double integration method sa unang span. For the second span naman, ang mangyayari, ganito siya class, yung EI, basta tandaan nyo, pinapalitan natin yung parenthesis ng ganitong symbol kasi nga ang meaning kapag negative ang nasa loob niyan, i-disregard natin siya sa computation. So, this will be EIY prime for the first integration equals negative 24, x squared over 2 minus 6, x cubed over 3 plus 6 times, do not forget that this is a multiplication, so wait lang Ilagay ko lang class yung multiplication sign, so ito na siya, and minus 25x minus 3 squared over 2, and of course, ang gagamitin na natin ay c sub 3 na, no? So ayan na siya. So that will be equal to, simplify nyo na lang siya as negative 12x squared minus 2x cubed plus 2 the quantity x minus 1 minus 25 over 2 x minus 3 squared plus c sub 3. Might as well for EIY, that is, ganito na lang. So I hope nagagets niyo yung process natin of integration, no? Madali din lang naman yun class. So negative 12 tapos x cubed over 3 minus 2, x to the fourth over 4, plus 2 times x minus 1 to the fourth over 4, minus 25 over 2, times x minus 3 cube over 3 plus c sub 3x plus c sub 4. So therefore, ang kalalabasan ay negative 4x cube minus 1 half x to the fourth plus 1 half x minus 1 to the fourth minus 25 over 6x minus 3 cube plus c sub 3x plus c sub 4. Okay? So, na-establish na natin yung dalawang double integration. So, ang pangalawa is determine the boundary conditions and solve for C1 to C4. So, dito class, sa una, malamang ang support lang natin is itong roller support na A. And reference, considering AB, di ba, iseset mo yung point A na x equals 0, di ba? So, ang gagawin natin, since deflection lang yan, di ba? Ang nakalagay dito, at roller support A, when x equals 0, the deflection or y equals 0. So, gamitin natin itong previously derived na equation for EIY. EI0 equals 4 0 cube minus 1 half times 0 to the fourth plus C1 times 0 plus C2. So, therefore, the value of C2 is 0. So, ayan, nakahanap na tayo, class, ng unang arbitrary constant. Next, dito tayo, class, sa span natin sa BC. Ngayon, meron tayong fixed support na i-consider and that is at point C. Eh di ba kapag fixed support, meron tayong i-consider na dalawang boundary conditions. So at point C, the slope is equal to 0. At the same time, the deflection is equal to 0. And considering segment BC class, the value of x to be considered here is equal to 5 meters. Kasi di ba, tingnan nyo to, 1 plus 2 plus 2 is 5 meters. So tingnan natin, at fixed support C, when x equals 5, y prime equals 0. So, gagamitin natin, class, itong equation ng EIY prime. So, negative 12, substitute nyo yung 5 squared, minus 2 times 5 cube, plus 2, 5 minus 1 cube, minus 25 over 2, 5 minus 3 squared, plus C sub 3. So, automatic naman, class. By the way, lahat yan EI kasi nga, the beam is prismatic, di ba? So, pag prismatic, it means constant yung kanyang flexural rigidity. So, yan magiging 0. Mahahanap mo, class, na ang value ng C3 natin ay 472. So, may 472 na tayo. So, lastly, meron pa nga tayong isang boundary condition at point C, where x equals 5, dapat ang deflection niya rin, class, ay equal to 0. So, ganun din ang nangyari at fixed support, x equals 5, y equals 0. So, EI 0 is equal to, isubstitute nyo, class, dito sa equation natin, yung 5. And of course, do not forget that the value of C sub 3 class is equal to 472. So, negative 4 times 5 cube minus 1 half times 5 to the fourth plus 1 half ng 5 minus 1 to the fourth minus 25 over 6 ng 5 minus 3 cube plus 472 times 5. Remember na yung C3 is 472 plus C sub 4. Ang ending, ang C sub 4 natin is magiging 9,000 negative 9853 over 6. Okay? So, meron na tayong C2, meron na tayong C3, and meron na tayong C4. So, ang kailangan na lang natin is yung value ng C1. And this time, i-utilize nyo na, class, yung ating continuity equation. Isa lang naman ang continuity equation, as I said earlier, dapat lang yung slope at B considering AB is equal to the slope at, deflection at B considering AB must be equal to the deflection at B considering BC. So, ito na siya. Pero, considering point B dito, class, ang x natin dyan is equal to 4 meters considering segment AB. Pero, considering segment BC, ang x natin dyan equals 0. So, I hope that is clear. Inom lang ako. So, ang mangyayari, ito na siya, sinet ko na siya as x equals 4 meter. EIYB equals 4 times 4 cube minus 1 half 4 to the fourth plus C sub 1 times 4 and C sub 2. Eh sakang diba itong C sub 2 natin ay 0. Eh sir, paano yan naging 0? Malamang kinompute na natin yun kanina, diba? Nandito siya, oh. C sub 2 equals 0, class. Okay? So therefore, ang mangyayari, so EIYB equals, pag sinimplify mo to, magiging 128 plus 4C1. Or simply, YB equals 1 over EI ng 128 plus 4C1. Considering naman BC, ang iseset natin na value ng x ay 0. So, isubstitute nyo lang, class, yung 0. So, everything will be cancelled out. Kasama na to, kasama na to. So, this will be 0. This will be 0. So, all of them ay 0 din except dito sa negative 9853 over 6. So, EIYB is negative 9853 over 6 class. Or simply, Y of B is equal to 1 over EI, this time negative 9853 over 6. So, after nyo class ma-establish yan, ang next step is i-equate lang naman natin sila. Okay? Pag inequate nyo, ang mangyayari, maka-cancelled out si EI. So, cancelled out class ang EI natin. And therefore, mahanap na natin yung value ng C1 which is negative 10,621 over 24. Okay, so sa wakas, nahanap na natin yung C1 to C4. So, pwede nyo na class i-substitute dito sa ating EIY prime and EIY. Both in AB saka ni BC. So, I already did that. So, ito na siya for span AB. EIY prime is 12x squared minus 2x cubed minus 10,621 over 24. EIY equals 4x squared minus 4x cubed. Pardon, no? 4x cubed ito, class. 4x cubed minus 1 half x to the fourth minus 10,621 over 24x. EIY natin for span BC, EIY prime is negative 12x squared minus 2x cubed plus 2, then x minus 1 cubed minus 25 over 2, x minus 3 squared plus 472, and EIY prime EIY na lang to. So that will be 4x cubed. So negative 4x cubed, then minus 1 half, tama ba? Minus 1 half x to the fourth, tapos plus 1 half x minus 1 to the fourth minus 25 over 6 ng x minus 3 cube plus 472x minus 9853 over 6. Okay? So, kapag na-establish na natin class yung equations, alam niyo na yung next step, balikan na natin yung problem. Question A, determine the deflection at internal pin. So, paki-correction ulit, this must be internal pin. Okay? So, paano yon? So therefore, since ang tinatanong class ay deflection, kahit alin dito class sa dalawa ang gamitin nyo. Kasi yung point B is part of span AB and yung point B is part ng span BC. By continuity equation nga, kahit alin sa dalawa class, dapat equal yung kanyang deflection. So B is part of both AB and BC class. So therefore, ang mangyayari, paki-correction na lang, pag sinubstitute natin class, di ba nga kapag x equals ay at point B, ang gagamitin ko kahit alin sa dalawa. Yun yung rule kahit alin sa dalawa. Kapag sinubstitute nyo yung value ng x dyan class, considering BC, x equals 0. So kapag sinubstitute natin, negative 4 times 0 cube, minus 1 half times 0 squared, which is, will be cancelled out, cancelled out. Ito naman, cancelled out siya. So as this one, cancelled out din ito class. So ito rin. So ang matitira is negative 9853 over 6, diba? Or negative 1642.1667. So, para mahanap nyo yung deflection at B, just formally divide it by EI. So, sa mga ayaw maniwala na kung gagamitin natin itong EIY for AB, gamitin nyo class yung x equals 4 kasi nga, considering point B here, that is 4 meter from the leftmost end of the span. Okay? So, subukan natin yon para masiguro natin tama. So, 4x cube or 4 times 4 cube, tama ba? Then, minus 1 half ng 4 to the fourth minus 10,621 over 24 times 4. So, chinecheck ko lang. So, ang lalabas ay negative 9853 over 6 then or negative 1642.1667. So, parehas yan class. Tama dapat. Okay? So, at least na-establish na natin na ito yung deflection at B. Pangalawang tanong class, what are the slopes at B? Gusto ko ditong magbigay ng emphasis sa word, I am using the plural form of slope which is slopes lang naman, di ba? So, ibig sabihin, hindi lang class isa yung slope natin. Actually, tama yon. Kasi nga, sa continuity equation natin, yung slope at B considering AB is not equal to the slope at B considering BC class. So, ang gusto kong i-point out dito class, magkakaroon ng dalawang slope sa internal pin. Ulitin ko yan magkakaroon ng dalawang slope sa internal pin. Yung isa, considering span AB, and yung isa, considering sa span BC. Okay? So, of course, considering span AB, just substitute x equals 4. Considering span BC, just substitute x equals 0. Okay? So, ito na siya. Considering span AB, I substituted them. So, ito magiging negative 378.5417. So, therefore, ang magiging sagot is negative 378.5417 over EI. While for BC, just substitute x equals 0, ang magiging sagot natin class ay 472 over EI. Okay, no? So, ayan siya. 472 over EI siya. So, therefore, ang mangyayari, uulitin ko, ang tanong class dito sa B, what are the slopes? So, therefore, hindi lang isa ang tamang sagot, but dalawa. So, yung una para sa AB, yung sunod para sa BC. So, the slopes are B, is negative 378.5417 over EI kung ang i-consider natin is yung span AB and 472 over EI kung ang i-consider natin class ay ang BC. So, I hope that is clear to every one of you. Basta tandaan nyo, sa internal pin, dalawa talaga ang slopes dyan, class. So, lastly, ang tinatanong for letter C, what is the slope and deflection at the 25 kilonewton load? So, yung 25 kilonewton load class is nasa span BC. So, nandito siya. So, pag tiningnan natin, yung one note natin class, no? Nandito siya. So, yung 25 kilonewton is at x equals 3. Kasi nga, ang reference natin is yung leftmost end. So, para mahanap mo lang class yung ating slope and deflection, ang gagawin mo lang, iseset mo lang yung x equals 3, pero ang gagamitin mo lang class is yung span BC lang. Kasi, nandun lang naman yung 25 kilonewton load. So, I hope that is clear. Diba? So, yun. Wait lang ah. And as I said, gagamitin nga natin yung x equals 3. So, therefore, in order to obtain the value of the slope, ito lang class, kasi nandun lang naman yung 25 kilonewton load. Just substitute x equals 3 here. So, ang mangyayari, EIY prime equals negative 12 times 3 squared, minus 2 times 3 cube, plus 4 times 3 minus 1 cube, and minus 25 over 2 times 3 minus 3 squared, then plus 472 equals 326. So, therefore, ang slope is 326 over EI. And the deflection, again, just substitute it, magiging negative 1,100 over 3 or negative 366.667. So, therefore, the deflection class is equal to negative 366.6667 over EI. So, yan na class yung slope and deflection at point na nasa 25 kilonewton load. Okay? So, to summarize this one, ang problem, unang tanong, what is the slope at B? Ang sagot natin is negative 1642.1667 over EI. Pangalawa, deflection at B pala to. Pangalawang tanong class, what are the slopes at B? So, dalawa nga siya, negative 378.5417 over EI and 472 over EI. Tama ba? Yes, may tama ka. Pangatlo, what is the slope and deflection at the point of 25 kilonewton load? The slope is 326 over EI while its deflection is negative 366.667 over EI. So ito na class, natapos na natin itong discussion natin. So please, I hope nga may natutunan kayo dito sa ating discussion. So the last example class will be this one, and of course this is connected ulit sa my internal pin. So if you want to understand this topic nga, I am telling you, you must be exposed in maraming examples nga. So dito na nga natatapos itong lecture video na to, and as I said nga, sana nga may natutunan kayo dito. So bye-bye sa lahat and ingat.